We need y, and then we need dy. Exactly the same thing we did with our example from the beginning. It's just that this was an indefinite integral, and now we have a definite integral. Same idea. Anybody?
Are we just substituting for negative mx?
Indeed. That is the problem. I can handle e to the x, but I don't know how to handle e to negative mx. Good. I need dy. Without dy, I cannot continue because this integral has dx. The new integral has to have dy. Anybody, please? The differential of this. Can anyone give us the differential of negative mx?
Is it 1 over mx?
When we differentiate this, we get negative m dx. The derivative of negative mx is negative m, but we are talking about the differential, so it's negative m dx. It's like negative 2x. The differential of negative 2x is negative 2. Perfect. So now, very nice. The only thing that we have to make up is a sign. That's even easier. Multiplying twice by negative 1. So now we have this, and we have this, which is dy. There's a negative in front. Do not copy the limits of integration. I know it's tempting. That's not possible. Good. So let's see what we have inside the integral, and then we'll find the limits of integration. So negative m and dx, negative m and dx, that's dy. And e to negative mx, do not copy anything in here as x and y in the same integral. That's not ever possible. Unless you have a double or triple integral, which we will not study in this class. So what do I replace e to negative mx by? Please, anybody?
E to the y.
Exactly. That's exactly it. Awesome. So now, remember, x is between 0 and b. So when I replace x by 0, I get the lower limit for y. When I replace x by b, I get the upper limit of y. When x is 0, how much is y? Bless you.
Thank you. It's also 0, right?
Perfect. When x is b, then we have negative mb. A little weird, but that's okay. That's what it is. Good. So then, negative outside, e to y from 0 to negative mb. Leave the negative sign outside, waiting patiently. Plug in the upper limit first, e to negative mb. minus when we plug the lower limit in and we get 1. You can distribute a negative sign right now, and it's 1 minus e to negative mb. I reversed it just because negative 1 times negative 1 is positive 1, and negative times e would be negative. Any questions on this problem? Okay, let's look at others. Maybe we want to look at a square root situation. Maybe we want to look at something like this. I would like to look at 63. But let's take a look at a square root first. Okay, I will choose 61. And this is the integral from 0 to 1 from 12x, the fifth root of 1 minus x squared dx. We had something similar last time, but it was a definite integral, not an indefinite integral. So good. So let's take a look. Y and dy. Can anyone help with y and then dy? So the integral from 0 to 1 from 12x, 1 minus x squared. It's continuous, guaranteed on 0 to 1, because 1 minus x squared doesn't have to be positive or negative. I mean, doesn't have to be positive. It's fifth root, so everything is perfect. Continuous on 0, 1. So can anyone give us an idea of what should dy be? See, on the previous example, the problem was in the denominator. Why the problem was in the denominator? Because 1 over x plus 1 cannot be simplified in any way, shape, or form. So I want to somehow change this into one term. And that's what we did. Here, I have a different problem. Any root of a of plus or minus b is fixed. It cannot, no one can simplify this in any way, shape, or form. So I would prefer this again to be one term. Because if it's one term, then I write something to a power 1/2, 1/5, whatever. So the problem with ratios, I don't want two terms in the denominator. The problem with radicals, I don't want two terms. I want in both cases to have one term so I can simplify. If it's more than one term, I'm stuck. If it's here a sum or difference of terms, I'm stuck. If it's here a sum or difference of terms, I'm stuck. I want one term in the denominator. I want one term under the radical. So coming back to our problem, what do you think should the substitution be?
One minus x squared.
Of course. We need dy. Because we cannot change the integral from x to an integral in y without dy.
Negative 2 dx.
To x dx. Good. So I have the x and the dx. Here they are. I don't have the -2, not a big deal, because I can rearrange 12 as -6 multiplied by -2. There is no need to make up the -2. It's there. I will just rearrange 12 as -6 and -2. So now I have the -2, I have the x, and I have the dx. So then I will have a -6 outside. Do not copy the limits of integration, wait. So the -2, the +6, and the dx will be dy. Now we have to identify this piece. Can anyone tell us how to rewrite that piece? The 5th root of 1 minus x squared. The 5th root of 1 minus x squared.
Put it as u to the 1/5
Yes, y to 1/5. Very good. If you use u, that's fine, but you have to write u to 1/5 du. You just have to be consistent. It doesn't matter. The letter is not important that you use, but it cannot be x. It can be anything else, but it has to be consistent. Now, remember x is between 0 and 1, but I need the limits of integration for y. So when x is 0, I get the lower limit for y. When x is 1, I get the upper limit for y. So when x is 0, the lower limit is when x is 0, the lower limit for y is
1.
Perfect. And when x is 1, the upper limit for y is when x is 1, the upper limit for y is?
Would it be 0?
Yep, it's very possible. Excellent, good. So -6, we increase the power by 1, y to 6/5 over 6/5 for 1 to 0. Oops. Good. That's what the limits are. That's what we, so I have to flip, simplify. So I have a -5 inside, outside, sorry. Then I plug in 0, so I get 0, minus, when I plug in 1, I get 1. So look at that. This is not what I meant to write. I meant to write 5, not 6. Good. -5 times -1. Again, I copied -6, but when I flip 5 over 6, the 6 simplifies and I only have -5. When I plug in 0, I get 0, but minus when I plug in the lower limit. When I plug in the lower limit, I get 1. -5 times -1 is 5. Any questions? Okay, so let's look at one more and then a word problem. Unless you want to practice more, of course. I wanted to look at something like this, like 63. Let's analyze 63. So the technique is the same. It's just that we have to copy or create new limits of integration. And the answer is a number, no longer a most general antiderivative. So 63, the integral from 0 to natural log 2 from e to the x over e to the x plus 1 dx. Good. Based on what we just discussed a few minutes ago, what is the problem here?
EX plus 1.
Exactly. Because the denominator is not one term. That's why I'm focusing on that. That is the problem. So let y be e to the x plus 1, but I need dy, without which I cannot move on to an integral in y.
E to the x dx.
E to the x dx. Beautiful. Look at this. Wonderful. Excellent. So how do I continue? What do I write? And of course, I need new limits of integration. Remember, x is somewhere between 0 and natural log 2. But first, let's identify what we have in the integral, and then we'll find the limits of integration. So what do we have? We have to account for everything. Nothing can be left over. There is no x anymore. We move the integral completely from x to u. I'm sorry, to y.
Would it be dy over y?
dy over y. Brilliant, thank you. And now carefully, let's find the limits of integration. Lower limit of x gives us lower limit for y. When x is 0, what do we get for y? E to 0 plus 1. How much is that?
2.
Very good. So now, when I plug in natural log 2, y equals e to natural log 2 plus 1. Here's the property. A raised to log base a of x is x. Yes, I can show you with a calculator, but this is an important property, easy to remember. So as long as this and this are the same base, the answer is this number. And they are the same base because natural log has base e. So this number is 2. So 2 plus 1 is 3. Let me also show you, you don't have to use the property. You can plug it in the graphing calculator. Here's how you do it. So we have E. Here's E. And in parentheses or not, you know me, I like my parentheses. 2, close, close. When I hit enter, the answer you will see is 2. As long as these two have the same base, the answer is this number. And these two have the same base, so the answer is 2. But 2 plus 1 will be 3. So finally, I need to determine the function, or I need to determine the antiderivative, the function whose derivative is 1 over y. Which function has derivative 1 over y? When I differentiate this function, I get 1 over y. There is only one function. Which function is that? It's a very important function. We need to remember that. Anyone, please? We need a function whose
E
derivative
negative 1.
Say it again.
E to the negative 1?
No, this is natural log of the absolute value of y from 2 to 3. So please remember, natural log of y is 1 over y. So we plug in 3, and we have natural log 3 minus when we plug in 2. So when we differentiate natural log over the absolute value of y, we get 1 over y. So reverse, the integral from 1 over y is natural log of the absolute value of y. Any questions? Any questions? So let me go back. Let's see. Do we want to work or on any other problem before we look at a word problem? Is there anything else that you would like to work on from definite integrals? Word problems, or we want to work on something else here?